Okay, starting with how to create an immutable map in Java and why do you think that is necessary? So the intent of asking this question is they want to know, do you understand about only maps or do you also know about how to create read-only maps and thus immutable maps? Why do we need them? How to create, right? So this is the intention of asking this. Now, what is immutable? Anything which cannot be changed. So basically we need a read-only view of a map where the content, the entries of the map cannot be changed. And if you try to add, delete, update anything to any of the elements in the map, you should be getting unsupported operation exception. It will also not allow you a null element. Now, why do we need it? The first and the foremost and the biggest reason is these kind of maps will not, like the caller, whenever they're going to call this kind of map, they will not be able to modify it. So we are giving a static or a read-only view of this. And as a result of that, it is inherently thread safe. So if you do not need to use any kind of synchronization mechanism or logs because it is read only, it has a fixed data already and you cannot change it. So inherently they are thread safe. Apart from that, it also reduces the number of bugs because any map which is mutable, again and again you're changing the values, it is more data error prone, will be difficult to debug, but to have a read only or a static view of a map is going to give you a better design, better readability, maintainability is there, thread safety is there, garbage collections issues are also not going to happen. So in a way, it is a very good way of coding. Now, why do we need to use it only for thread safety? No, we will see certain use cases also. This is one reason. Now, coming to the use cases, like in case of Spring Boot, you need the configuration properties, which will not be changing at runtime. So you can use these kind of thing map. Secondly, this is very important, the static lookups, like let's say the days of the week kind of a lookup, or you're trying to already have a certain mapping done. That mapping is not going to change and you do not want that to be accidentally changed. So you are going to map like the error code to error message, and that kind of static lookup is going to be used, like the underlying data structure can be an immutable map. And like I said, returning values that you, if you're passing in your code as a third party library, so that you want your downstream applications to be used, you do not want the caller to modify the data, right? So these are some of the use cases in which you should be using a immutable map. Now the question is, what are the different ways to create? As we can see, map.off is the latest way of creating an immutable map, Java 9 onwards. Before that, if it is Java 8 or older, there was a use case. We used to use this collections class and use the unmodifiable map method over there, which nothing but it acted like a wrapper on top of a underlying mutable map. So I'll show you in the IDE for a moment. Like, so what happens is there's a mutable map, ABCD. Okay, some key value pairs are there. That is mutable, means that can be changed. On top of that, you're putting a wrapper around it and presenting like collections.unmodifiable map. And that wrapper which you're creating is actually unmodifiable, right? So that is where we used collections.unmodifiable map. Not the current way of using it because it was used in the previous versions of Java 8 and older. But in the latest way of using is this. Now the limitation of using map.off is, as you can see, we have to define the key value pairs. So it is good for a smaller map. But if you want it to be dynamic, or if you want the mutable map, the underlying map to be changed in the runtime, then you should be using this collections.unmodifiable. So let me go to the IDE. See, this is the mutable map. Okay, I have already put some values in this and we are creating a wrapper. So this variable immutable map is the wrapper on top of this. Now I'm going to run this and you get this. Now see this fun thing. If I say I am going to put another value over here, another key value. Okay. Now I'm changing this underlying map. So I'm expecting this map to also change, right? So in a way, collections.unmodifiable map is not really immutable because the moment you are adding some more entry, this map is also changing. So in a way, it is not immutable. Like 100% it is not immutable. But in cases where you want that you're going to change the underlying data and that should reflect on that mapper, then this is a good use case. And another thing to notice, if I do immutable map dot put, and here if I just write something, okay, I need a string, anything, just I'm just writing. Okay, now this is a wrapper. This being a wrapper should not allow me to add anything. So this is one big difference which I wanted to show you. See, we are getting unsupported operation exception. Now, if we talk about the other way of creating, that is map.off, which is from Java 9 onwards, here you have a fixed set of entries. Okay, this is the fixed set of entries and it is a more convenient way. Like if I hover over this thing also, you'll be seeing that it is going to be suggesting me to use this. But the problem is it is only going to be for like a smaller, like you cannot have dynamic data defined over here, right? So how do we create this? Let's say I write immutable map, immutable new map, map dot off. As you can see, the different okay, so as you can see, there are so many different overloaded versions where you have to hard code the number of key and values. So let's say I give like this, okay, and now I'm going to print this out. Sorry, immutable new map, and also I'm going to do this. And let me also try to put something. Now let me run this. So in a way, using map.off is actually giving you a right immutability. So now you see this map I have printed. The moment I tried to add it, it gave me an exception. So this is in truest sense, the immutability is working over here, which didn't really work in case of this because we were still being able to modify the map. But this is giving you the right static read-only view of the map. So that is why this is the more preferred way. The only problem is it is not supporting you dynamic map address. So this is the thing which you have to answer. This is what you have to answer when you are asked this question. So next question is, what is the difference between dependency injection and dependency inversion principle, and if at all they're related to each other? So as we know, dependency inversion, DIP, we will call it DIP for dependency inversion, and we'll call DI for dependency injection. Little bit confusing, but there's a difference. In solid principles, D stands for dependency inversion principle, where we know that the modules that we write, where it actually has the business logic, should not be tightly coupled with my implementing on the concrete class. That is what it states. A high level module should have no dependency with the lower level module. So there the word dependency is coming in. Okay, so they shouldn't be dependent on each other. And that is going to help you to get loose coupling flexibility. We'll see that in a while. Like for example, I've given this example many times, a database. Today you're using something else, tomorrow you're using something else. So you shouldn't be having a tightly coupled code where you have, let's say, given that this is the PostgreSQL SQL implementation that you're using. No, it should not be happening like this. It has to be a generic thing. And that the way to implement that is using interfaces abstractions, right? Now, if you see this particular example, I have a message sender interface. And here my low level module is what? Email sender. My low level module will be WhatsApp text sender. My low level module can be a voice message sender. So the low level modules are the concrete of the implementing classes. I am not tight coupling it so that the high level module, the notification service, which is actually doing the notification, the business logic, there I can just say that, okay, this is the message sender which I'm passing in the constructor. I do not care what is the message sender is about in the class of notification service. My only job is I'll get a message sender. I'll send the message whenever you are calling send notification. Simple. Whether you are sending voice message or email or WhatsApp text, this notification service doesn't care. The code of this doesn't care. It is not tightly coupled. It only cares to receive an implementation of a message sent whenever it will receive from the caller. So in that way, this low level module, email sender, do you think email sender is anywhere related to notification service? I mean, they are of course related through the message sender interface, but is there any trace of the name email sender in notification service? No. That is what dependency inversion principle is. Now, coming to dependency injection, here the word dependency is about creating and managing the dependencies of your project, of your application. Let's say in the context of Spring Boot, we write the dependencies in the form.xml. So that delegation of responsibility to manage those dependencies is given to the framework itself, to the Spring application context itself. There the word dependency is used, and we are telling that the framework is going to inject those dependencies into my application. Like for example, through constructor injection, setter injection, field injection, we use this very famous @ AutoWared annotation. What are we doing? we're injecting that dependency that I don't have to write new object like this to create the object. I don't have to use the new keyword. The dependencies will get automatically injected. So this is a design pattern where the framework will give you the necessary dependencies that you need instead of me creating it. So I'm delegating the responsibility of creating the dependencies. So you have to understand the difference. DIP was a solid principles design principle, and this is a design pattern wherein we are achieving DIP only. Because you are injecting the dependencies, we are injecting that particular interface, the code will be different, right? Because we are injecting that particular interface, we are achieving DIP only. So in order to achieve DIP, I am using DIP. This is the small subtle correlation between the aim, the objectivity and the conceptual thing of DIP and DI is different. The usage of the word dependency is also very different for both. But DIP aims to create loosely coupled code, but with the help of DI also we are able to use the loosely coupled, create a loosely coupled code because we are delegating that responsibility, right? So both of them are actually helping me to achieve or to write an efficient code only. But the thought process or the conceptual thing is different for both. That you have to understand. Next question is, how will you implement caching in a Spring Boot application to improve performance? Now, if you're not being asked to write the code, for this question, you have to mainly answer in terms of the keywords. You have to use the right keywords. A follow-up question which can also be asked to you is, what is the default caching mechanism? That is why I've started with that. First, to give you a context of what is the default caching mechanism in Spring Boot, and then the third-party cache provider. So in Spring Boot in itself, uses concurrent map cache. This is the data structure, which is the built-in cache provider. Okay, but the use cases is this is used for very small scale application, and it will store the cache data in a very simple map like a concurrent hash. Okay, it's like a key value pair. It will be there and it will act as a cache, but it is used for small scale applications. And this will not help you with distributed data, right? If you want to share like distributed caching, it will not help you with that. And if you have a very simple caching requirement, low memory usage, limited number of concurrent users, and using in dev testing, then this kind of just for doing some kind of a POC kind of code, then this is useful. This is a default implementation. Large scale, big applications will not be using the default caching mechanism, the default caching provider which is provided in Spring Boot. That is where the third party caching solutions can come in. The very famous one being Redis, right? You can use different other cloud providers implementation also. So even Elasticache in AWS also has Redis as one of the implementations. So in that, how will you implement it? So Redis is a popular in-memory data store used as a caching layer. Why is it preferred? Because it supports data persistence, replication, higher. Now I talk about these terms a lot in my system design series. So you can check that out. You'll be able to get a better picture of what I'm talking about. So when Redis should be used, just the opposite of what we talked about. You need a scalable cache system, distributed caching behavior, the application response time is critical, data persistence, replication, fault tolerant, all of that. So you would choose an external cache provider versus over a default in memory whenever your application's scalability needs, reliability needs, performance needs are not met. How we are using it? In the pom.xml, we write Spring Boot starter cache and we give the Redis as the cache provider. Spring Boot starter data Redis. The starter dependency should bundle up all the dependencies. Then your main application should have this annotation of enable caching, at the rate enable caching. In the application properties, you have to define which port you want to listen to, what will be type cache.type is Redis. So now this comes to the code level. Now while you're talking about it, you just have to mention these keywords like enable, at the rate enable caching, so that your caching is applied to your entire application. You're using this properties defining this. You're also configuring the TTL. It's a very important thing when you're working with caching, the TTL, right? So that because you know the data is also going to expire at some point, right? So you don't want stale data to be shown to the users. That is why you have to set the TTL. And there are other annotations like at the rate cacheable, you're going to put it on top of the method, which is actually returning you the cached results. You'll use cache put to put the data in the cache. Or maybe just like a CRUD operation, you're doing update operation. Evict from the cache based on some logic, some business logic, some condition. So these are the keywords which you have to talk. Now, if you want a detailed video, you can comment down below where I can show you the code of how to implement this. But let me tell you this, it depends. It varies from company to company. Many companies don't even use Spring Boot Redis. Maybe they'll go for completely different, like for example, Aerospike. It's a NoSQL based cache provider. It works as a database, but it also works as doubles up as a cache also. So that is also being used in many different places, right? So it depends. Now you can let me know in the comments if you want me to show you the code just to do one simple POC program on this. I can do that. So the question which was asked to you, the intent of doing that was to understand if you know about how to implement caching. What is the difference between map and flat map? So either you may be asked to demonstrate that using, by writing a program, or maybe the conceptual difference, like where to use a map and where to use a flat map. So as we know, map means something to be transformed. So you want to transform some element into some other form, and that is why you use the map function. Like for example, here we have a list of names, and we want to convert that. Like we want to get the length of each word, like each name, right? And then put that into a list. We can also maybe try to let's say convert each name into lowercase. So that is also another transformation. So that is what we use map for. Now, when do we use a flat map? A flat map is okay. Map was one-to-one mapping. John, length 4. Jane, length 4. So one-to-one mapping, like a map we have key value pair. But flat map is one-to-many map. What does it mean? If you have multiple stream, list of list, for example, that you want to merge it. Okay, so like for example, over here we have two lists. So there's a name, John and Jane, that is one list, and Jack and Jill is the second list. Now, what do we want to do is we want to print all the names which is given over here. So you have a list of let's say you have 100 categories like that. Let's say employees of different departments, and you want to get all the employees across all departments. So in that case, what you have to do, you have to flatten it one to many mapping. So you have to flatten it. So the term we call is flattening multiple streams into single one. To do that, what we are doing, the same thing, nested names dot stream dot flat map. Now, what we are trying to do is over here we are calling this flat map and we are saying stream over now each of them. Each like you've streamed over this. Now stream over each of them and convert that and collect that into a list. So if you do this, then you are going to get multiple streams data into one single stream and eventually collect it into one single list. Another example is you have these sentences and you want to get the different words from these sentences like this, hello world like this. So all of them are given in different lists, right? I mean, it is a list of string, okay? It is not one single string. So from one single string, getting the words is easy, but you have multiple strings which are inside a list. So over here, what we are saying is stream it, each of them, each sentence, stream it, and then split it by the delimiter of space. So you're splitting hello, world, then Java and map. So each sentence you're splitting it and collecting into a list. So in that way, we are able to get this. Okay. So this is the difference between map and flat map. Next question is what is Liskov's? It is Liskov's substitution principle, and can you explain that with an example? So now this is again the L of solid principle. We also learned about the DIP, the dependency inversion. Now what is the Liskov substitution and how is it related to day-to-day example? So what is Liskov substitution principle? Say that objects of a superclass should be replaceable with the object of the child class, the subclass, without affecting the correctness of the program. So if you have a base class like parent and child, if I'm substituting in place of the base class, I'm using the derived class, then my functionality of the program should still work. So why is it important? Let's understand in the context of a Spring Boot application. So for an example, you have a class called API response. Now API response can be of many different types. Let's say based on the HTTP status. It can be 2xx, it can be 3xx, it can be 4xx, any kind of HTTP response can be there. So what we are doing is we are creating different classes and extending this API response, wherein I'm going to manipulate the message and the status code accordingly. If it is success, it will be 2xx. If it is error, let's say it will be 5xx. Or if it is client-side error, I'm going to keep it 4xx. So in this way, I have multiple classes. Now, when I'm using it in my controller, I am not writing the exact child class. I'll just write API response. Return what? The API response. What am I going to return? What concrete class I'm going to return? It is going to depend on my business logic. So here, I am returning API response. Now, whether I'm returning success or error or client-side error or redirection error, whatever is the error, that I'm just returning the child class of it. So my success response is substituting my parent class of API response, and the program will still behave correctly. But what if there was a class which was extending API response and it was not extending, it was extending the API response, but whenever I'm using it, I'm let's say for example, I'm not passing the correct constructor parameters, which is why it is breaking. That could have also happened. Then my Liskov substitution principle would have been violated. So the crux, the basis of this is, if you're using a base class and a child class and you're creating child classes, remember, always remember, your child class should conform to the specification of the rules which is led by the base class. Because we know that the constructor will anyway have an implicit supercall, right? So that should not be breaking. And more than that, what is important, the correctness of the program should be correct. Like, I cannot be arbitrary, right? I am writing new success response, for example, and I'm not passing the status code over here, right? So that is not the right way of writing the code. If I'm using the parent class and I'm using the child class, I have to understand that anywhere I can use any of the child classes, wherever I'm just writing the base class. So in place of the base class, anywhere I'm going to return any of the child. So that is what your Liskov substitution principle is about. The next question is the plus plus operator thread safe in Java? If not, then why is it not? So plus plus operator, as we know, it is actually not thread safe. Reason being, it happens. I've already discussed about this in my race conditions video as part of the Java threads and competency playlist. I have a full in detail video on this. So in short, if this kind of question is asked, you have to tell about the 3 steps which is happening, right? So first, the example is that there are 2 threads. Both of them are reading the current value, but due to context switching, one thread has incremented the value and the another thread is still holding the old value. So there's a possibility of incrementing the value twice. And that is the reason we say that this operator is not thread safe, which can result to data inconsistency and race condition. What can we do to make it thread safe? Most popular solution is to use atomic integer. Like, for example, mostly we'll do this plus plus with integer, right? So is to use some kind of atomic class like atomic integer, or basically to use synchronization techniques. The next question is, it's not a question, so to say. First, I want to talk about the JVM architecture because I do not have any video on my channel about JVM architecture, and then we will come to the questions which can come around JVM architecture. So first, try to understand this JVM architecture, right? This is very important for experienced people to know this. Otherwise, we'll not understand what is happening behind the scenes, right? So basically, in JVM, there are 3 different areas or 3 different components: class loader, the runtime data area, and third is execution engine. Class loader and these 3. Class loader, as the name says, is going to load the classes. Again, class loader has different types. We'll come to the runtime data area. Anything you need to do some instructions you have to execute, so you need data for that. I mean, you need some storage for that. That place, the memory area you need, where you're going to store in your intermediate values, classes, variables, all of that. Your stack and heap and everything comes under your runtime. In the runtime, what data you are using, that data you want to store some. Third is execution engine. Now, your .java eventually gets converted to .class, right? So that also, basically, your Java compiler is converting that into bytecode. Now, that bytecode needs to be converted to machine code. Who will be doing that? The execution engine is responsible. So broadly, we have 3 components. Now, class loader has different phases: loading, linking, and initialization. Loading these dot class files which are just compiled into the memory. Then we have to verify if the bytecode is conforming to the required format. Otherwise, you may do some try to corrupt the system. So we have to. There's a certain, you can think of it. There's a certain syntactical framework or a syntactical let's say there's a blueprint, and the verification is basically going to see if the bytecode which is formed is actually conforming or aligning to that blueprint. Then is initialization, right? All the variables, the static variables, static blocks, like we initialize it before the main method is called. Now, there are 3 types of class loader: bootstrap, extension class loader, application class loader. What is bootstrap class loader? Now, you see, when you write system.out.println, do you import that system class? No, because we know system class is within java.lang package, which is the default. And we also don't import java.lang package. It's automatically that java.lang package gets imported. How? There is a certain jar called runtime jar. From that, this bootstrap class loader is actually going to pull the jar file into the memory, thus loading the core java.lang's libraries into the memory. So we don't have to worry about system class. For example, and we don't have to worry about any classes which is coming from your core Java, let's say java.lands package. Next is extension. As the name suggests, extension, any third party library, like example OJDBC. Okay. So any third party library which you are using, but it is part of your Java's framework, those additional libraries are getting loaded. Who is loading that? Your extension class loader is loading that. And third is your application class loader. As the name suggests, the code that you have written and the code, your main.java, which is converted to main.class, those are loaded by the application class loader. Okay, so we are good with the types of class loader. So point number one is done. Coming to the runtime data area. This is also divided into certain areas. Method area, your class level data, like the static variables, all of that is stored over there. Heap, like we know the objects, the things, anything which is relative to object, your instance variables. Stack, like the function call happens, so your local variables, execution frames, operands, stack is going to store. PC register will track which execution is currently in progress, which instruction is currently in progress, and native methods. So this is what is happening in your runtime data. Finally, we have execution engine. Now, since childhood, we have read interpreter versus compiler. Interpreter will do it one by line. Compiler will do it all together. So JIT compiler is trying to fasten up the performance of a Java application, because any line, let's say any frequently used method, which is converted into a frequently used bytecode, that it is going to compile it, do it one time, and that is going to compile it into the native machine code, into 0, 1 for one time. And we are again and again going to reuse that basically, so that our execution is faster. Anything which is duplicate, redundant calls are happening, converted into native machine code for faster execution. Garbage collector, as we know, for cleaning up the unused objects. And JNI is allowing the JVM, so any interaction that you want with the native library. This is about the execution engine. So in short, we come to know three components. A very brief overview I've given about all these three components. Now, what are the questions? These are the questions which you may get asked. Why do we need a class loader? So now you know the types of class loader. Now you can give the example of the system class. The different runtime areas you can talk about what is stored and where. Why do we need the JIT compiler versus interpreter? Garbage collector, how does it work? Steps, what actually happens in the linking phase? And why is the bytecode verification important? So all of this you will be able to answer. Because like I said, in the linking phase, linking means verification, right? And also preparing the memory for this. So linking, one thing I forgot to tell you is your variables are pointing to some memory address, right? So that resolution will also happen in the linking. So that is also very important. And one question was, why is bytecode verification important? This is what we also discussed, right? Just to conform to a certain standard. What if your code that you have written is somehow trying to corrupt the system? I mean, the execution JVM itself. So for that reason, before even executing the bytecode, we have to understand that we have to verify the same. The next question is, what is the difference between composition, aggregation, and association? Three very commonly used terms, but very often confused also. So association, as we can see, is the outer uh, box, the more generic relationship it defines. Inside that, we have aggregation and composition. Okay. So anything, if any two entities are having some association, which means they have some relationship between both of them. But that relationship is that each one of them can still exist without the other one. Okay. What are the examples? Very simple. Your teacher and a student also is an association. Teacher and student are related. But if teacher doesn't exist, the student will still remain as a student. If student doesn't exist, this teacher will still remain as a teacher. Person and address. So you are living at some address. If you are not there, that address will not cease to exist, will still exist. If the address is not there, okay, you are still there as a person. So this is what your association relation is about. Loosely coupled. Okay. There is no dependency, there is a relation between both. Aggregation means it is also called like your has a relation. Okay. So this some entity contains another entity, like company and employees. Very, very common example. Or maybe you can think of it like your school contains students, your college will contain your students, your university will have departments. So it is like a contains relation. It is contained within that. A library contains books, but it is also that they can exist independently. It will be contained, like your person and address is not like you are contained over there. You can still exist independently. I mean, in aggregation, it is a part of relation. A employee is a part of company. But if the company is shut down, the employee, of course, will not remain as an employee of that company, but it can still exist. It will not die. The employee will not die if the company is shut off. The books in the library will still remain as books in some other part of the world. So the existence is not that if it is closed, the books can get moved, your departments can get moved out of the university if the departments have if the university gets shut down. So although there's a contains by relationship or a part of relationship, they can still exist independently. So this is so far about aggregation. Composition is more strictly and tightly bound, where the child entity cannot exist without the parent only. So, like over here, a school and a classroom, your house and your rooms. If the house is not there, your rooms will also get destroyed. A very simple example is your heart, your organs of the body within a person. So, person has a heart. So, it is like your heart, if your person dies, the heart will also no longer be used, right? I mean, it will no longer exist. So your battery of a phone, so if the person, if the phone is not there, the battery is also dead. So in that way, it is more, that is why it is inside of this, there's a strong correlation. They are tightly coupled and they cannot exist without each other. So this is what these terms mean. Okay, so how do we define this when we do the ER mappings, entity relationship diagrams and all? How do we map it? So in Hibernate, we use this at the rate entity to map it to original table, like the actual ORM when we are doing. So there's a person class, so there's a person table in the DB. Now I'm seeing a person and address have an association, which means they can exist without one another. So we'll use one-to-one mapping and we'll join it using address. So our person is mapped to one address, okay, and there's a one-to-one mapping. How do we define aggregation? So like we said, in aggregation, they can still exist independently. So we can have one-to-many or many-to-one relationship, where the life cycle is, the content is independent. So library will contain many books. So we will write like this, there's a one-to-many relationship and we'll join it. Next is composition. Here also we can have this house and room. But here we have this orphan removal equal to true, which means if my child entity is room, if I'm removing this house, if I'm deleting the entry of the house, my rooms should also get deleted. So that is the mapping which we are talking of. So in association, there's loose coupling. They can exist independently. Aggregation is a weaker, but they can still exist independently. It is a containing relationship. Remember, association was not containing anything. So aggregation, composition, both will be containing other entities, but in aggregation, it can exist independently, but in composition, it cannot exist. Okay. Okay, next, why string is a good key for hash map? How should you choose a key for your hash map? And why should the keys of a hash map be immutable? So I've just clubbed the most frequently asked questions around that. So while we discuss this, hope you get the answers of all of it. So first of all, you have to understand that a hash map's underlying data structure is what? I've also in detail covered about internal working of hash map, internal working of hash set. So this diagram is going to show you that. Underlying data structure is a hash table, which is nothing but an array. Okay. And we call the name of that array, we call it buckets. Like the each entry we call as each bucket, right? So now when you're asked that why string is a good key, the very first answer, it is simply because it is immutable, which means the contents of the string cannot be changed. We know this, right? It cannot be changed. You cannot modify. Once you create a string object, you cannot modify that. That is one reason why it is a good key. Now, what does it entail? What does it mean? So when your string is immutable and the content cannot be modified because of that, okay, due to this, the hash code remains constant. So our string class has the hash code method which comes from the object class. It overrides that. Okay, so it overrides the hash code. Now hash code has a role to play when it comes to generating the hashing function, using which we determine in which bucket my key is going to get stored. As we can see, John Smith is a key. It is getting stored in bucket number 152. We think of it the index. This 152 is determined by doing a hash code calculation on top of this key. So when we do the hash code calculation, after that we determine this is the bucket in which we should be stored. Similarly, we do it for all of them. Okay. Uh, Now this hash code will return the integer value, and then as it is mentioned, used by the hash map to determine where in which bucket you're going to store that particular key value pair. So great. So till so far is clear. So one thing we understood here, string is immutable, and because of this, every time, see, if John Smith got modified or any of these keys are getting modified, if it was not immutable, then today I'm storing in 152. Tomorrow, when I'll come and retrieve this particular value of John Smith, I want to see what is the value, that is the phone number, let's say. Tomorrow, I'll be trying to find it in some other bucket because I know the address, the location of John Smith is this. Tomorrow, if I come and I'm not able to find it, it is because the hash code has generated a different integer value, a different index value, which is wrong. That is the biggest reason why it should be immutable. And why? Because of this, the hash code doesn't change. And if it doesn't change, then we have the correctness. Like we are able to store the values and retrieve the values also correctly. So that is the entire story about why string being immutable is considered a good key for hash map. Now, what are the properties? Like, if a good hash code, how should it be? There are two important things. A good hash code should do two things. One, it should be consistent. That every time I'm generating it, it should always return the same value. Like I said, it should always point to this particular index. It should not generate sometimes 152, sometimes 253. That is a wrong hash code. Like, the implementation of hash code is wrong. And secondly, it should distribute the hash codes uniformly to minimize collision. So, if at 152 right now I have this particular entry, so collision, which means in the same, every time I'm calculating it for different names, I'm always getting the same hash code. Then what will happen? The other indexes are free. Okay, and we are only putting in this, and again we have to do traversal in this. So basically that is collision. Now if I randomly, if I evenly distribute all the entries, I will have one over here, one over here, one over here. That is the even distribution. I'm utilizing all the indexes properly. That is a uniform distribution. So that is what your hash code should also be doing. Two things: consistent and even or uniform distribution of the keys across the underlying data structure. That is the hash table. Now if you see this code, let's say we have a person class, name, age, and address. These are the three fields. Now, uh, let's look into the equals method. When okay, I just want to talk about this because it goes hand in hand. When I say equals, try to understand. When I say two persons are equal, I can say if they have the same name, if they have the same age, and they have the same address, which means two persons are same. Like they say staying at the same address, their age is also same and their name is also same. Then the person is same. If I was like the name and age only and not address, then it is possible that there are two different persons with the same name and age but staying at two different addresses. So that is why if I have to determine if two persons are equal, I have to consider these three fields, and that is what this equals method is also doing. Compare the fields name, age, and address. This is how the equals method's implementation is. Now look at the hash code calculation. Simply, we will do objects that hash these. So these three entries I'll take and I'll hash it and generate a hash code out of it. Always have to take these three because whoever is determining my equality, those fields are the ones which I have to store in the hash code also. So these two are in that way related always. Otherwise, it will again end up in incorrect bucket. So how should I choose a key for hash one? This was the question, right? How should you choose the key? Of course, you have to choose a key which is immutable. And why we have to choose a key? Because, like I said, the hash code has to be same. So string is immutable. All the wrapper classes that we have are immutable. So those are good keys. Okay, you should not be using primitives. You should not be using any mutable objects like list or any classes. Most of the times you'll always see we write map and then we write string, or map and then integer. Okay, map and then object. So we use the wrapper classes which are immutable in nature, or if you write your own immutable class, you can use that also. But never use primitives, never use mutable objects. The next point is about, apart from immutability, your hash code and equals. So what is a well implemented hash code and equals is what the example we have shown over here. So that thing has to be taken care of. And why should keys be immutable? We have already discussed. You can just pause and just read this for a while. Okay. So conclusion, it is a good key because it is immutable and it has well optimized hash code and equals. And when we are choosing, we should prioritize immutability keys because that will help us in preventing any kind of unpredictable behavior in case of hash based collection where hashing plays a role. Great. What is the difference between API gateway and load balancer? So, like I said, this series is for backend developers, Java backend developers. And it is not always going to be related to only Java, only Spring Boot, only microservices. You you need to have your basic system design knowledge also. So that is why I've included this question, very commonly asked question. What is the difference between API gateway and load balance? So you have to understand what is the primary purpose of each of these components. API gateway, as the name suggests, something to do with the APIs. So it will manage and control the routing of the API request in the microservices architecture, right? So where you would want to map it to different microservices. So when I'm saying slash user, I should be going to user service. If I'm going like putting slash order in my HTTP request, I should be going to order service. So who is handling this? API gateway is handling this. Apart from also handling the authorization, authentication, it will route and aggregate the API calls from the client to different microservices. That is the main problem which API gateway is trying to solve. Along with that, it has some other add-ons: monitoring, throttling, authentication, authorization, all of that. Okay, so this is what your API gateway is trying to do. AWS API gateway, Kong, Zol, all of that is doing the same thing. So that is the reason why we are using API gateway. It can double up as something which will control the monitoring. It will also control the throttling. Those are add-on behaviors. Main thing is to route the API calls to the appropriate microservice. Load balancer, as the name suggests, is trying to balance the load. Now that I've given it to other microservice, to the designated respective microservice, now how am I going to balance the load? Which means when I have peak traffic, how am I going to say that to which instance of that microservice I have to give? So let's say I have three instances of order service. I have four instances of user service. Now when slash order is coming, I'm going to order service. Now order service has instance 1, 2, 3. To which instance I'm going to give that put that traffic to? I mean put that request to. That is going to be determined by a load balance. So the primary focus is to distribute the traffic to ensure no single server gets overloaded. And you can just pause and read about this. I have also done a video on load balancer in my on my channel. You can check through that also. But the main intent of this question was to primarily point out the difference between API gateway and a load balancer.